Quadratic functions and models. First, let's do a review on quadratic functions. To be a quadratic function, you basically need your variable term, typically x squared. This makes something a quadratic function. Now, in general, we write a quadratic function with these two pieces too. These are the linear parts to the quadratic, but this makes it a quadratic. So this is what we call general form. And so we'll be working from general form. Now, when we graph a quadratic, we look at the a part. If the a is greater than 0, positive number, the graph that you will get is a parabola oriented upward. A parabola oriented upward, if that a is positive. And since the parabola is oriented upward, what you'll get is a minimum value. Okay. Now, to find this minimum value, we need to find this point right here, which is called the vertex. First thing we need to find is that the vertex, or first thing we see is that the vertex is located along the axis of symmetry. The axis of symmetry is found by taking the opposite of b, which is here, divided by 2 times a, which is the a here, and this will give you that vertex, the axis of symmetry. Then we take that number that we just created, we put it inside the function itself, and that answer becomes our minimum value. Now, if the a is a negative number, if the a here is a negative number, we will get a parabola whose orientation is downward. And a parabola with an orientation that is downward is going to have a maximum value. Okay. To find that maximum value, we again need the axis of symmetry here, which will be x equals the opposite of b divided by 2 times a. And we'll take that value and we'll put it inside the function itself, and that will give us a y answer that will be the maximum value for the parabola. Now let's look at quadratic business models. Now we'll do a little review of the linear business models that we went over. The first one was the cost function, and we use a linear equation to describe that. And one other note is that when we did the cost function, you notice that the slope was positive. It had a positive slope. The graph went upward. Now, furthermore, the input for this, for the x's, was items, whereas the output was cost, which is basically money. Okay, so remember this: for the cost function, the input was items, and then we eventually got money out, and the slope was positive, which means the graph went upward. Or the m here, the number here is positive. Next, we found the revenue function, which was a linear. It did not have the b, so we did not see any revenue that we could start off with. We had to sell items. The slope on this one was also positive, and the input for this function, we input items, and the output was revenue, which is essentially money. And again, the slope was positive, so it was also going in an upward direction. Next, we looked at the supply function. The supply function was a linear, and the slope for this was positive. So even when you graphed it, the graph went upward. Now these were a little different. input right here was price. The input was price. And then the output for this was items. So the X here represented a price. Then we had the consumer surplus and the demand function, which is also a linear function we were working with. And the slope for this one was negative. So for the consumer, the graph went downward. The input was price. So the further the price went up, the less items the consumer actually bought. So the input here is price, output is items. And the slope is negative. This is a review of the linear business models. Okay, I want to make a few moderations to these two right here. Because the input is price for supply and demand, you will also see P being used as the input variable. And also, items is often represented as Q. So sometimes you won't even see a supply and demand. When the output is items, you'll see the letter Q. But we will tell you whether we're dealing with a supply or demand. But typically you can tell by the slope whether the slope is positive or negative, whether you're dealing with a supply or demand. So again, the Q will stand for items. P will often replace X for price. Next, how do we get a quadratic revenue? Often in this class, we'll be developing our own revenue functions. The revenue functions will be made using this format. Revenue will be made by taking whatever stands for the price and multiplying it times the demand, whatever stands for the demand. Essentially what this means is that the demand is how many items people are buying off the shelf. The price is what they're buying it for at that very moment. So if you know how many items they bought and how much they paid for each item, you simply multiply the price times each of those items and you now have your revenue. So this is another way of producing revenue. In this case, our price will be represented by the letter P. And the demand function, we're going to use our old linear back here, which is demand equals mx plus b. Or should I say demand equals mp plus b. mp plus b. And you see that when we put this together, the price times a demand function, a linear demand function, what happens is that when they combine, you'll get mp squared plus bp, and hence we now have a quadratic function. What's good about a revenue that went from a linear to a quadratic function is that we know that the m that was being used for the demand function here was negative. Therefore, the m here is still being negative. And a quadratic that leads with a negative will be a parabola that has a maximum. So, there is a way to get a maximum revenue now. Now that we can combine price and the demand function. And our goal is to find out what is this maximum revenue. What is the price that will give us the maximum revenue? Which will be here. There's the price. And also, what is the revenue? What's the maximum revenue that we will get? So two things. What the price, the items at, and then what maximum revenues we will be getting. Now, let's find the price that maximizes revenue and the maximum revenue itself. So, two things. Okay, we're given that Q equals negative P plus 300. Well, this I know is a demand function because this is items as an output and price is the input. So when I see price input, output items, and a negative slope, I know that I'm dealing with a demand function. Okay, so to find revenue function, A revenue function is made out of price being multiplied by the demand. Okay, so this has to be memorized, that revenue is made out of price multiplied by demand. So this will be revenue equals P. Demand function is the negative 3P plus 300. So revenue function is negative 3P squared plus 300P. What I have here now is a quadratic. And a revenue that's a quadratic means that when you graph it, because of this negative coefficient here on the P squared, we'll have a max. To find the max price, I need the axis of symmetry formula. So that'll be P equals the opposite of B all over 2A, in which our case this will be negative 300 all over 2 times negative 3, which will be, the negatives will cancel and we'll get 300 over 6. And so the price that will maximize the revenue is $50. So I need to charge $50. The question now is, what is the maximum revenue that I'll get when I make my price $50? Well, I go back to my revenue function and I put in 50. I get negative 3 times 50 squared plus 300 times 50. Now, 5 times 5 is 25 and then 2 zeros. And from here, 5 times 3 is 15 and 3 zeros. 3 times 25 is 75 with a negative and 2 zeros, plus 15 and 3 zeros. And then when I add this together, I'll get positive $7,500. So this is my maximum revenue when my price is $50. Number 2, same question. I have Q, which is a function for items, and P is a price that's input, and I notice that my slope is negative. Therefore, I'm dealing with a demand function here, and I want to find the maximum revenue. So again, revenue is found by taking the price and multiplying it times demand. So revenue equals P times negative 2P plus 320. This will give me a revenue function that is negative 2P squared. You notice I put a P in here and didn't have it before. That just tells us our input. Input for revenue is price. Just kind of reminding me. Plus 320P. So now I have a revenue function that when graphed creates a parabola. Therefore, we're going to have a price that's going to represent the axis of symmetry, and we're going to have a revenue here that's going to represent the max amount of revenue. So let's find it. So axis of symmetry formula, which is the opposite of B all over 2 times A. My B in this case will be negative 320 all over 2 times A, which is negative 2. And this is negative 320 over negative 4. And the negatives cancel, we get positive, and 4 goes into 32 8 times with a 0 left over. And so my price now needs to be $80 to maximize my revenue. My price being $80 maximizes my revenue. But what is my revenue? How much money am I really getting because I priced everything at $80? Let's find out. So revenue function, I put 80 in here. Negative 2 times 80 squared plus 320 times 80. And 8 times 8 is 64. So 64 and 2 zeros. And let's see, 8 times 2 is 16. 8 times 3 is 24, plus 1 is 25, and 2 zeros. Okay, now from here, 2 times 4 is 8, 2 times 6 is 12, and 2 zeros, plus 2, 5, 6, and 2 zeros. And then when I add these together, I'm going to get a revenue of $100 sorry, $12,800, okay, for my revenue, given that my price input was $80. Still looking for the price that maximizes revenue and the maximum revenue itself. I'm given a situation where 400 items sold when we charged $8. But we were able to sell 600 items the next week when we sold them at $4 each. So, what is the price that we need to charge to get what type of maximum revenue? Well, in order to find that, I need to find the demand function. Demand functions are basically linear, where the input is price and the output is items. So I need to set up the information in that same manner. Input, a number for input and a number for items. So price, I have an $8 price that I use as input, and the output was 400 items. Then when we input a price of $4, the output was 600 items. This creates a point. This point right here, where the input is price, output is items, I can find the slope. So let's do a change keep and change keep here. So we have m equals 600 negative 400 4 negative 8. And this gives me 200 all over negative 4, which is negative 50. Okay, so I have a negative 50 for the slope. Now, to get a linear equation, I'm going to need to use the point-slope formula, where I put in a point and a slope. So, here's a point and there's a slope. It doesn't matter what point I use as long as I use the same xy from that point. So, the opposite of y will be negative 400. My slope is negative 50. My x is negative 8. Now I'm going to distribute my negative 50, and I get negative 50x and a positive 400 here. Now add 400 to both sides, and I end up with y equals negative 50x plus 800. Now remember, all of this is the demand function, so I can write this as Q equals negative 50p plus 800. Okay, the x's and y's is just a generic algebra, and the p's and q's is the business calculus that shows you what things stand for, what's the input and what's the output. Okay, now let's find the revenue. Revenue is found by the price multiplied by the demand. So this will be revenue with the input of price, we have P, and the demand function, we found that to be negative 50p plus 800. So this will be revenue. When I distribute my P, I'll get negative 50p squared plus 800p. And this is a quadratic, and quadratics form parabolas. Since the leading coefficient is negative, I know this parabola's orientation is downward and it will have a maximum. So what's the price that will maximize this revenue? So P equals the opposite of B divided by 2 times A. This will be negative 800 divided by 2 times negative 50. This ends up being negative 800 all over negative 100, which ends up being positive 8. So, this lets me know my price needs to be $8 to maximize my revenue. Now, what is the maximum revenue? Let's go back to the revenue function and put in $8, an $8 price. So I'll get negative 50 times 8 squared plus 800 times 8. And 8 squared is 64, so negative 50 times 64. 8 times 8 is 64. Okay, and from here, I'm going to multiply 5 times 64. Well, 5 times anything cuts it in half. So you get 3, 2, and 0, 0. Okay, plus 6400. And my revenue from putting in a price of $8 will be $3,200. We're still looking for the maximum revenue that will produce the maximum price that will produce the maximum revenue. The next scenario is this. In this area, we're charging to build houses $190,000. When we charged $190,000 per house, in that area we were able to sell 50 homes. The second area that we went to, we decided to lower the price of the houses to $170,000. Well, this time we were able to sell 70 homes in that area. Now the question is, what is the price that we really should sell our homes at that will maximize our revenue? So, in order to maximize revenue, revenue function is made out of price times demand. To find demand, demand is made out of an input of price and an output of items. Okay. So I want to set this scenario up where we have price as input and items as output. So I see here that when the price was $190,000, we were able to sell items, 50 houses, total 50 houses. And then when we lowered our price to $170,000, the items, which were the houses, left at 70. Okay. So I want to find the linear demand equation from this, so I'm going to need a slope. And I'm going to do a, let's do a keep and change. Keep and change to find the slope. So we have 50 and a negative 70, and that's all over 19000, 4 zeros, minus 1, 7, 1, 2, 3, 4. Okay, so let's simplify this, and I'm going to have negative 20 on top, and I'm going to have 2 and 4 zeros, 1, 2, 3, 4. Okay, I'm going to simplify that further. The zeros will cancel out and the 2's will cancel. And I'll be left with a negative 1, a 1 here, and 3 zeros. Okay? So that's my slope. Now, let's build that equation. So we have y minus y1 equals m, x minus x1. And the opposite of y, let's use this guy right here, will be negative 50. The slope will be negative 1 over 1,000. And my x will be negative 190,000. Okay, let's distribute this, and we'll get negative 1 over 1,000 next to x. A negative negative here will give me positive, and the 3 zeros will knock out the 3 zeros there, leaving me with 190. Now I add 50 to both sides, and I get y equals negative 1 over 1,000 x plus 240. Okay, so this is the demand function. So this is regarded as Q equals negative 1 over 1,000 P plus 240. Okay, so now we have a demand function. Now we can multiply times price to get revenue. So my revenue will equal my P times negative 1 over 1,000 P plus 240. Alright, so our revenue based on price will be negative 1 over 1,000 P squared plus 240 P. Alright, now let's, again, this is a quadratic. The quadratic has a negative coefficient, so we know it has this form or this orientation where you're going to have a maximum. Let's find the price that gives us our maximum. So P equals the opposite of B divided by 2 times A. Well, what stands for B this time will be negative 240. And what stands for A will be the negative 1 over 1,000. Okay, now to clean this up a little bit. If I take the reciprocal of this, that'll be 1,000, which will go in the numerator. So what I'll have is, let's see, let's simplify this 2. So 2 goes into 224, we get 12 with a 0. And this flips over to a single 1,000 in the numerator. Okay, and then the negative and negative gives us positive. So all of that's going to end up giving us 1, 2, and 4 zeros. 1, 2, 3, 4. Oh, sorry. So this is the price that we really need to sell a house at. If we sell a house at $120,000, we will get a maximum revenue. So this is going to be our price to sell the house. Now, what about our revenue? Let's take a look. Revenue, when you put in the price of $120,000, will be 1 over 1,000 times 120,000 squared plus 24,000, and let's put that in there. 120,000, and looks like time for a calculator. Let's see how far I can get without needing one. I'm going to work with this one first. I know my 12 times 12 is 144. I have 4 zeros here, but with the square that'll give me 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And this is all over 1,000. Okay, so I'll work with that part later. This will give me, let's see, a total of, I have 3 zeros here. It'll eliminate 3 zeros there. Too many zeros. Got rid of. And that leaves me with negative 144 and 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Okay. Now, when I work out this part, I'm going to get a positive 882,000,000. When I add those together, I'm going to get positive 144,000,000. So, therefore, my revenue will be $14,400,000.